and thank you, the organizers, for inviting me to present here. So I will start by talking about antibodies, and then the other speakers will add other strategies to this. Let's see if I... Okay, here are my disclosures. So as we all know, there are different sites that are susceptible to neutralization on the envelope trimer. And then I highlighted here the antibodies that are now in clinical evaluation, and they target 5 of these epitopes. And in addition to the ones that I highlighted here, there are also bispecific and trispecific antibodies in clinical testing, as well as protein, but also as AAV delivery. But just to recap a little bit about the breadth of activity of these antibodies. So here in this heat map, a variety of different antibodies were tested against pseudoviruses representing different viral clades. I indicated here in blue the earlier antibodies that had been in clinical trials. Just to show here how there are significant gaps in neutralization. In the heat map, white means no neutralization, green low neutralization, and then the darker red is the best neutralization. So this new generation of antibodies that now have been in trials since 2014 have greater breadth of neutralization. However, depending on the different classes of antibodies, they have different activities against different clades. So for example, V2 antibodies, they're not as broad as against clade B, whereas V3 antibodies almost have no activity against clade AE. So this is a way to illustrate how really a combination of antibodies is really what we need to think about for both therapy and prevention. And then here I'd like to also show this because we have to think about diversity, not only broadly speaking in HIV, but also within a person living with HIV. So this is these are phylogenetic trees from a study that we completed recently, where each of these branches of the tree represent one individual. And then this shows how distant the viruses are across different individuals and even within an individual. For example, this person here who has many different types of families of HIV, if you will, within their reservoir. And then it's known that these viral populations evolve over time prior to ART initiation. And it is also known that over time, neutralization breadth evolves and some individuals go on to have these broadly neutralizing antibodies, but that also occur in parallel to developing resistance to such antibodies. So that's about the antiviral neutralizing activity of bNAbs. But one of the reasons that we're excited about antibodies for HIV cure is because antibodies are known to interact with the immune system and have other functions in addition to neutralizing free viruses. So antibodies can they have the potential to deplete infected cells through triggering ADCC, for example, or they may be able to enhance CD8 T cell responses by forming immune complexes that enhance antigen presentation. So these are observations that have been shown in cancer therapies, and now we want to see if we can demonstrate that similar functions can be triggered with antibodies in humans. If we are able to do that, then antibodies have this ability to limit the establishment of the reservoir if they are administered with early ART or perhaps at ART initiation. They may then reduce the reservoir by depleting infected cells, or they can also enhance immunity, leading to long-term control. So what do we know so far in terms of these potential activities of antibodies? So from preclinical studies, it's been shown that antibodies can in fact accelerate clearance of HIV-infected cells in vivo models. And then there's been a series of studies of antibodies alone or in combination with other strategies in non-human primates, leading to long-term control of the virus after the intervention was discontinued, that was at least in part mediated about CD8 T cell responses. So this demonstrates in preclinical studies that these other activities of antibodies can in fact be triggered and be part of the phenomenon of control. However, we don't really understand what distinguishes these animals that go on to control the virus long term and the ones that don't. And then we are just in the very beginning of understanding of what antibodies can do in this space of long-term control when it comes to clinical studies. But we still have a lot of open questions as to how to design and conduct the studies. We don't know the best time for cure interventions. It may be that these interventions could be more effective during ART initiation, for example, or during analytical treatment interruption, or perhaps we can reach the goals that we aim to reach during suppressive ART. We do not know how long interventions need to be. It may be that a few doses of a given combination of the strategies will not be sufficient, and then the exposure to the intervention will have to be long-lived. And it may be, and I think many of us believe that antibodies alone won't be able to reach this remission or long-term control in a large number of individuals, that we will need combinations with different strategies, but we do not know exactly which combination, which strategies, which modalities will be most successful. So I'll use the two antibodies that we've been working with at Rockefeller. So they are 3BNC and 1074. 3BNC targets the CD4 binding site, and then 1074 the V3 loop. They've been in a series of clinical studies, small clinical studies so far, and we tested either single repeated doses of the antibodies, either sub-Q or intravenously, and then in general they have been very well tolerated. And then we have tested these antibodies in different scenarios. We have shown that when they were given in combination during ongoing viremia, they led to decrease in viral loads, but over time there was selection of resistance. Whereas if we give the antibodies after ART discontinuation in individuals that had achieved suppression, the antibodies can in fact maintain suppression, as I'm going to show, in participants that have sensitive viruses to both antibodies. However, across these various studies, we realized that there is resistance, pre-existing resistance in people with HIV. And then the last point is that these antibodies have been modified to be long-acting, and then they in fact have much longer half-lives. So the most recent study that we completed, we tested the two antibodies over a period of 5 months, where individuals either received the antibodies after they discontinued the ART, or they received the antibodies during suppressive ART. And then the first question that we wanted to address is, can the antibodies maintain virus suppression during this switch period? And what we found, in fact, is that in our cohort, 5% of the participants were able to continue to maintain viral loads below 200 copies for the period of antibody dosing. And this is what's illustrated here in this Kaplan-Meier curve in the green line in comparison to an early study where we only gave 3 doses of the antibodies. And then out of these participants, there were 2 individuals that maintained suppression beyond 48 weeks. A parallel study was conducted with the same antibodies, very similar design. And here the difference is that the individuals had initiated ART during early HIV infection. And then it was a placebo-controlled study. And then you see here that it's the antibodies were, again, in fact, able to maintain suppression in 5 out of the 7 participants in comparison to placebo. So in these 2 studies, the participants we did not attempt to pre-screen participants for bNAb sensitivity, but after the study, in one of the 2 studies, we tested PBMC samples for sensitivity of the proviruses by this assay called the PhenoSense assay, which is currently the only clinical assay that we may be able to apply in clinical trials. This assay generates a pseudovirus from PBMCs in this case, and then these pseudoviruses that are meant to represent the quasi-species in the reservoir of an individual with HIV, they are used to infect cells in the presence or absence of different antibodies. And then by doing so, we are able to know what antibodies may work or not for a given participant. So when we applied this PhenoSense assay in parallel to genotyping, so looking at the envelope sequences to 1074, one of the 2 antibodies, in our participants, here what I'm trying to show is The gray bars represent the time to viral rebound from discontinued ART. And then the colors here by the phenotypic PhenoSense assay or by the envelope sequence methods illustrate what the participants that were predicted to have resistance versus sensitivity. So first thing to point out is that in the PhenoSense assay, we had a failure of 30% to be able to amplify the virus. And then the other point is that in some individuals, we found resistance by this method. There was discordance between the phenotypic assay and the sensitivity assay. But here, the phenotypic assay correlated with an early viral rebound. But then we have other examples where there was prediction of resistance here, and then even in these two participants that maintained suppression for an extended period of time, and it wasn't predictive in those cases. In contrast, when we applied the methods in circulating viruses in plasma, then we saw that there was again some failure in amplifying and getting the result, but in other cases we were able to detect resistance to 1074 as it was expected because there was a period of monotherapy to this antibody. So in this cohort, either assay, genotypic or phenotypic, would not have reliably predicted clinical outcome. So in addition to being able to suppress viremia, what do we know in terms of antibodies perturbing the HIV reservoir or enhancing immune responses in clinical trials? So this is going back to a study that our group published several years ago, looking at humoral immune responses over time after individuals received a single infusion of 3-BNC. So what this graph here is showing is the neutralizing activity in serum against a panel of pseudoviruses representing different clades. So in the yellow here and then over a period of 6 months. So looking at the change over 6 months. So in the control group, which were individuals that did not receive the treatment, there was a variability in terms of activity. Whereas in the individuals that were not on ART and received the antibody, there was increasing breadth in the circulating antibodies. And this increasing breadth paralleled the difference in these are all sequences and diversity of sequences over time. So there was enhancement, broadening of immune responses that paralleled increased diversity in viruses that were circulating. In terms of T-cell responses, this was work in collaboration with Daniel Kaufman. We looked in a study where it was an ATI study, so individuals discontinued ART, maintained suppression under antibodies only. What they demonstrated was that there was an increase in GAG-specific both CD4 and CD8 T-cell responses over this period of time, in contrast to individuals that had not received the antibodies. And then they were also able to show that there are new responses to new epitopes. And this is something that has more recently been demonstrated again in a study by the Danish group, the ECLEAR study, showing that when antibodies were given at ART initiation, there was also an enhancement of or maintenance of higher T-cell responses over time. In terms of the reservoir, in our study where the antibodies were given only over 6 weeks, we interrogated the size of the reservoir by a viral outgrowth method. And it's essentially in this short period of time of the intervention, we did not see a change in the size of the reservoir. More recently, in the study where the antibody was given over a period of 5 months, we interrogated the size of the reservoir by this newer method that was developed by Christian Gabler. Here, the provirus is amplified using 4 different probes to 4 different envelope regions. This is duplicated. So after you have these amplifications, you pick the wells that are positive to at least 2 or more of these probes, and those are then sent for sequencing. So what this allows us to do is to not only measure the viruses, the sequences that are more likely to be intact, the ones that have 2 or more positive probes, but we are also able to learn the sequences and then therefore understand the clonal diversity of the reservoir. So we can confirm intactness, and then we can study composition. So we applied this method in our study where we analyzed the reservoir over 6 months. And here what we found, so this is looking at intact viruses versus defective, because we are able to confirm intactness because we have sequences, in individuals before therapy and after therapy. And we saw that there was a decrease, a small but significant decrease in the size of the reservoir by this method over this period of 6 months, in contrast to individuals that were just maintained on ART. They did not receive an intervention. And then what's important to show is that we did not see, in contrast to intacts, there were no changes in defectives. Moreover, if we look at the types of sequences that one could obtain, look at the different types of defectives, there was no change in any of the categories of different defectives, whereas there was a significant change in the intacts in the individuals that received the antibodies. So this was a small to moderate change in the size of the reservoir, but it was statistically significant in the individuals that received the antibodies. And then we combined both the groups that receive antibodies under suppressive ART or antibodies alone. However, we recognize that this is a very small first study, and then we hope to be able to expand on this in future studies. So to summarize, our studies and others have shown that antibodies, these two antibodies and other antibodies, are able to decrease viremia in clinical trials, and that viral suppression can be maintained for an extended period of time in participants that have sensitive viruses to begin with. There's some indication that immune responses are modulated, modified during antibody therapy. We have not yet found or modified these responses in a way that led to long-term control in a significant number of individuals. And in terms of the reservoir, again, we also have very early indication that immunotherapy with a combination of two antibodies can, in fact, impact the size of the reservoir and the representation of the intact proviral reservoir in a period of time. However, across all of our studies, we continue to face the fact that the viral reservoir diversity is a challenge, and development of newer, better combinations and better understanding of reservoir diversity continues to be a priority. So with that, I'll conclude and thank all of our collaborators, but most importantly, our study participants that come forward and participate in these very complex studies. Thank you.